Dabbahu is an active volcano located in the remote Afar region of Ethiopia. Its only eruption in recorded history happened on September 26, 2005. But before that, the ground around it bulged and there was a whole swarm of earthquakes, over 130 events. About a week later, the eruption of Dabbahu sent ash and rocks into the air, leading to the evacuation of 6,300 people from the area, and cracks started appearing in the ground, some of which were over 3 feet wide. But the most important thing is that the eruption created a series of fissures stretching nearly 37 miles. The longest one, 1,600 feet long, became known as the Dabbahu Fissure. The appearance of these cracks is truly a remarkable event. You could even say it's unprecedented in the field of science. Such a sharp and massive split was equivalent to several hundred years of tectonic plate movement, and those few hundred years packed into just a couple of days. Thankfully, since the eruption was predicted and people were warned in advance, human casualties were avoided. Although in some sources I found information about one person being injured and a lot of animals, goats, camels, and donkeys, dying. Most of them just fell into the cracks. Nearly continuous seismic activity, including tremors, was recorded along the segment from September 4th to 30th. The total length of the fault in the desert was 34 miles. And now researchers believe it will eventually become a new ocean. Wait, hold on. The scenario and the faults are making me kind of confused. I'll make myself a coffee first, and then we'll figure it all out. An unobtrusive reminder to do something under the video if you happen to forget. And thanks for understanding you know what. So what's the deal with our rift? The tectonic magmatic segment of Dabbahu is at a plate boundary, and from below you probably wouldn't notice it. But if you go higher? In this photo, the area between the Dabbahu and Gabo volcanoes is cut through by deep cracks. The fault is marked with arrows in this photo, and here's another fault. The photos were taken near the volcano sometime after the eruption. But all these geological cracks didn't appear in 2005. Scientists believe that the whole thing started long before that eruption, and they're really excited about this fact. You can understand them. Scientists believe that right now, in real time, they're witnessing the birth of a new ocean. How's this happening? Well, just follow the idea and the map. The African and Arabian plates meet right in the Afar Desert in northern Ethiopia. But unlike some other plates, they move apart in a rifting process at a speed of less than 1 inch per year. And this has been going on for the last 30 million years, during which the 186-mile Afar Triangle and the Red Sea have formed. The Dabbahu volcano is located along the Somali plate. It's considered a small plate and sits right here at the junction between 5 other bigger plates. And right now, it's in the process of splitting from the African plate. Researchers predict that the land along this region, known as the East African Rift, will eventually break off, creating a new island made up of eastern Ethiopia and Djibouti. A new island and a new sea. And they think this might happen in about 1 million years. From a geological point of view, 1 million years is like a blink of an eye. In fact, it's even faster. Whoosh! It's a piece of a continent that becomes an island. So scientists already knew that the separation process had started. But when the crack opened in 2005, some geologists immediately said it was proof of a new ocean forming. Others, however, weren't convinced. So they did what real scientists do and started looking for evidence. And they found it. A study conducted by an international team of scientists and published in Geophysical Research Letters showed that the processes leading to the formation of a fault are almost identical to those happening at the ocean floors. This once again confirms that, in the future, an ocean should form in this region. Just so you understand, the same rifting activity is slowly pulling the Red Sea apart, making it wider. Scientists not only confirmed the theory of a new ocean forming. Using seismic data from 2005, they were able to reconstruct the event and show that the fault extended over its entire nearly 37-mile length in just a few days. Dabbahu, a volcano at the northern end of the rift, erupted first, then magma burst through the middle of the rift zone and began to unzip the rift in both directions. Ridges on the ocean floor form as a result of magma pushing through faults, just like before. It's just that scientists never thought a huge part of a ridge could suddenly break apart like that. However, the process is so similar that now researchers even see this spot in Africa as a lab for ocean ridges. In a way, it's now possible to watch events in the ocean without actually diving into the ocean. Convenient. Talk about saving money. So scientists carefully analyzed what was happening around the volcano and found that in some places the ground shifted by about 26 feet, and enough magma to fill in a football stadium over 2,000 times poured into the crack between the plates. Of course, this is an uneven process because the three plates don't really coordinate with each other. They just drift apart at different speeds. The Arabian plate moves away from Africa at about 1 inch per year, while the two African plates spread apart even more slowly from 0.5 inches to 0.2 inches per year. As the plates move farther apart, molten rock seeps deeper into the cracks, slowly cooling down. This forms new land, and in a million years, the Red Sea might flood into the rift. So that's basically how oceans are born. In unstable cracks in the Earth's crust, where plates are moving apart, melted rock fills the gap and hardens. The new crust pushes the old crust away from the crack toward the edge of the continent. Eventually, the oceanic crust slams into the continental one, and thanks to plate tectonics, gets pulled down and recycled deep inside the planet. For example, the Pacific Ocean came about during this process. It started 190 million years ago when the Earth's crust split and fresh lava poured up from below. And it's exactly because of this continuous cycle of creation and destruction that no ocean floor is dated to be older than 200 million years old. But let's get back to the volcano in northern Ethiopia, because it turns out the locals have figured out how to make use of the eruptions and rifts. Many lava flows on the mountain consist of obsidian, black volcanic glass, and the crack that opened up in 2005 released smoke and steam with a very strong smell of rotten eggs. Since water's extremely scarce in the desert, the local Afar people came up with a brilliant way to get it. They would dig a hole near the opening from which steam and gases would escape. Then around this hole, they built a low circular retaining wall topped with branches and grass. All of this created a surface for condensation, and the steam collected in the hole. And that was it. The only problem was the level of contamination in this water with various chemicals and minerals found in volcanic areas. Sometimes drinking the water would kill the goats. So to test its quality, the locals would hold a shiny piece of obsidian above the hole. If a milky deposit formed, it meant the spot wasn't good for collecting water, and they would just dig another hole somewhere else. I don't know if the Afar people still do it, but the method is genius in its own way. But let's get back to our ocean of the future. It's expected that the Red Sea will eventually merge with a rift in about 1 million years. In the end, the new ocean will connect with the Red Sea and the Gulf of Aden, a branch of the Arabian Sea between Yemen on the Arabian Peninsula and Somalia in East Africa. But the process of forming something as huge as an ocean is really slow. So before it appears, a gulf will form in the middle of Africa first, then it'll turn into a sea, and only after that will it start to grow, slowly turning into an ocean. And to figure out where the Gulf will be and then the sea, you need to take a closer look at the East African Rift. It's believed that it started forming at the beginning of the Miocene, about 22 to 25 million years ago. A fault or rift is a divergent boundary of tectonic plates. Basically, this is where the African plate is splitting into two parts. When the process is finished, one plate will become two, the Somali and Nubian plates. Technically, they already exist. At least scientists have already given them names. The separation is happening very slowly, at a rate of about 0.23 to 0.27 inches per year, but the fault stretches for thousands of miles. And all of this is the future boundary of the ocean. If you look at the map, it turns out that a whole list of countries is breaking off from Africa and, along with the Somali plate, is moving eastward. You're probably underestimating the size of the new island or even continent that's supposed to form in the end, and that's a mistake. Let's take Tanzania as an example. It's on the list of places that are separating, but it's almost right on the equator, which means modern flat maps make it look smaller. In the meantime, Tanzania's territory could hold 7 Englands if you push them really tight together, and exactly 9 Icelands. Plus, you can fit 2 Californias in Tanzania at once, or one whole big Texas. And this is just one country from a pretty big list. Overall, the new island will be impressive. And although it's too early to talk about it, I think it could totally be a contender for the title of a new continent. Kind of like a bonus for the creation of a new ocean. This bonus is not the only one. The creation of a new ocean itself can be a good thing for biodiversity, just like what happened when Pangea split, leading to the appearance of a huge number of new species. Pangea is actually a great example to think about the consequences of a new ocean forming. New oceanic air circulation paths began to carry moisture into the interior of the continents, where it had once been very dry and conditions there became, well, normal. Meanwhile, fresh, shallow waters opened up along new continental shelves where marine life thrived. These shelf edges are prime real estate if you're a mollusk, fish, or something along those lines. The same could theoretically happen with the formation of a new ocean. In other words, there's hope that the central part of Africa, which is rather dry and landlocked, might transform. But how exactly this will happen is hard to say. It's just going to take a long time. Actually, even small tectonic shifts can lead to radical changes in the world above. One striking example is the formation of the Isthmus of Panama, a narrow strip of land connecting North and South America. While it's just a tiny barrier on a global scale, it didn't even exist 20 million years ago. But when the Pacific plate sank beneath the Caribbean plate, it pushed up the ocean floor and caused underwater volcanoes to break through the surface. The water connection between the oceans began to narrow and eventually disappeared altogether. This sent warm waters northward, creating what we now know as the Gulf Stream, which raised temperatures in northwestern Europe, giving the region its relatively mild climate, and hence the animals and the plants. Everything has changed thanks to a single narrow strip of land. But why do these massive movements happen in the first place? The Earth's crust is made up of large tectonic plates, which are rocky, irregularly shaped chunks that constantly collide, slide over each other, or drift apart. Scientists have been trying for a long time to figure out what triggers such grand-scale processes. For example, a 2020 study suggests that the process of rifting or the movement of tectonic plates is not always smooth and steady. Sometimes it can involve sudden jolts along the way. Yes, just like in the Afar region, and this could be caused by increased pressure from rising magma. It's like an overinflated balloon. If you blow it up too much, just a tiny bit of pressure can make it pop. However, the study doesn't provide answers to all the questions scientists have. Unlike any other rocky planet in the solar system, Earth's surface is made up of a giant puzzle with pieces that are always in motion. Each piece is a tectonic plate. I like the comparison of the plates to croutons floating in a really hot, thick soup. By the way, some old computer simulations actually showed it this way. They recreated the movements of continents alone, showing them drifting on a non-dynamic blue background of the ocean. There are actually two theories about why these plates, or croutons, are floating or crawling somewhere, moving. The first and most common theory is that the plates move because of convection currents in the Earth's mantle. Heat makes the magma rise, it cools down closer to the surface, and then sinks again, and so the cycle continues. This circular motion causes the plates in the crust to move. The second theory is known as slab pull. It suggests that movement is caused by the weight of heavier, denser slabs sinking into the mantle and pulling along smaller slabs with them. Can this movement stop? Well, nothing lasts forever. Eventually, the Earth's mantle will cool down enough that this planetary scale conveyor will stop and the plates won't be able to sink into it anymore. At that point, not only will the movement of the tectonic plates, which has been the driver of evolution, stop, but so will the carbon cycle. In a way, our planet will end up looking like Mars or Venus. Right now, they don't have any active moving plates on their surfaces. The good news is, we won't need to worry about it. Well, at least not for us, people watching this video, because the cooling of the mantle will take a really long time. Scientists have calculated that this will happen in about 1.45 billion years, which is long before the sun is expected to expand into a red giant and swallow us up before burning out. The death of the sun's expected to happen in about 5.4 billion years. But still, what will our world be like when the key planetary processes come to a halt? It'll be different. After a while, the mountains will disappear, erosion caused by winds and waves will shave down the mighty peaks into hilly plateaus. This is because mountain ranges are formed at the edges of tectonic plates, and they're constantly growing very slowly. Geological processes make the mountains taller, but at the same time, the peaks slowly crumble away, so the mountains grow but maintain their height. When the processes stop, the mountains will slowly wear down. Eventually, most of the very, very flat continents will be underwater. Subduction zones will no longer exist, so while earthquakes will still happen from time to time, truly massive ones with a magnitude of 7 or higher will forever be a thing of the past. At the same time, most of the explosive volcanism around the world will die down, though volcanoes won't completely go extinct. Eventually, as things keep cooling down, the last volcanic fires on the planet will go out, the mantle will be relatively cold, and Earth will turn into a dead planet. Sort of like Mercury. Probably before that, Earth's liquid core will cool enough to stop convection, leading to the failure of the planet's protective magnetic field. A stream of energetic particles from the sun will blow away our atmosphere, and then it'll boil off the oceans. Basically, after the tectonic plates stop moving, the Earth will slowly start to decline. The planet will become more and more flat and boring, and then it'll just fall into whatever's left of the sun. But that's going to happen in a very, very long time. Compared to that, you might as well say there was an ocean in Mongolia the day before yesterday. Yep, there really was an ocean in Mongolia. Over 400 million years ago, hot rocks rising from the Earth's mantle ripped through the crust and gave rise to an ocean that stuck around for about 115 million years. Back then, Earth looked nothing like it does today. That was the Devonian period. The Devonian period is often called the Age of Fish because fish ruled the oceans while plants were slowly spreading across the land. Back then, there were two big continents, Laurasia and Gondwana, and a long string of microcontinents that eventually formed what we now know as Asia. These microcontinents gradually bumped into each other and merged over time. Back in 2019, researchers started fieldwork in northwestern Mongolia, where the rocks from these collisions that shape continents are exposed on the surface. They were studying the age and chemistry of ancient rock layers when they suddenly discovered that about 410 to 415 million years ago, an ocean had opened up in the region. They called it the Mongol-Okhotsk Ocean. I mentioned it for a reason. Experts believe that the way the Mongol-Okhotsk Ocean formed was likely similar to what's happening now near the Red Sea. So it turns out ever-shifting tectonic plates not only push up mountains and carve out valleys, but also make oceans open and close in cycles. It's like an accordion the size of a planet. New lakes. This might be obvious, but I'll say it anyway. It's not just oceans that form as tectonic plates shift, and not just mountains either. So in the same Africa, there are already a few lakes that have come into being. Let's explore them a bit more. The first lake is called Malawi and lies between Malawi, Mozambique, and Tanzania. It's one of the largest freshwater bodies in the world. It stretches 350 to 360 miles in length and reaches a maximum width of about 47 miles. Plus, it ranks 4th by water volume and covers an area of 11,400 square miles. Also, this lake has a unique feature. Its water layers don't mix. Still, we're here to talk about how the lake was formed, not its other fun facts. Let's save those for another video. Lake Malawi is located at the southern tip of the East African Rift and was formed due to the splitting of the African tectonic plate. This process, in turn, created a deep depression. It was historically believed that Lake Malawi is about 1 to 2 million years old, but new research shows it's much older. The groundwork for the lake basin started forming around 8.6 million years ago, with conditions for a deep water basin coming together roughly 4.5 million years ago. In other words, it's really, really ancient. Another lake formed by tectonic plate movement is Lake Tanganyika. It ranks second in freshwater volume and depth after Lake Baikal, and it stands out as the longest freshwater lake in the world. It can also be considered quite ancient. Tanganyika is over 1 million years old. To be precise, it's divided into 3 basins of different ages, which, when the water level was lower, might have been separate bodies of water. The central part of the lake formed between 9 and 12 million years ago, the northern area about 7 to 8 million years ago, and the southern part appeared relatively recently, 2 to 4 million years ago. In short, nature really knows how to create bodies of water. The vanishing of the sea. And yes, nature is also really good at wiping out bodies of water. A good example is the Mediterranean Sea. Due to the slow movement of tectonic plates, it's possible that it could vanish completely in the future. In fact, the evidence that some object might disappear from future maps is pretty simple. Just take the convergence of the African and Eurasian tectonic plates. This process started around 100 million years ago and led to the shrinking of the oceanic basins between them, which resulted in the formation of the Alps. You get it, right? These kinds of geological processes started a long time ago, and since they're not stopping anytime soon, the Mediterranean might also end up squeezed between the converging tectonic plates. It's hard to say exactly when it will happen because predicting the movement of tectonic plates is just impossible. However, it's clear that the Mediterranean Sea isn't going anywhere in the next millions of years, so you don't have to reschedule your vacation. The mountains of the future. Scientists keep digging into Earth's past so they can model and predict its future. One of the goals of modern science is to imagine what mountains will look like eons from now. We already know that many mountain ranges like the Himalayas and the Alps were formed because of tectonic plate collisions. It's literally the foundation of the foundations. Well, researchers from Utrecht University predict that in about 200 million years, the Somali and Indian tectonic plates will collide. This will lead to the formation of a mountain range comparable to the modern Himalayas. And it won't just be some neat strip of highlands, but a curved mountain chain in the strait between Madagascar and Africa. If we break down the process, tectonic shifts could push the northwestern part of India 31 miles deep under the Somali plate. But as the plate continues to rotate, this region would eventually rise again. And by the way, scientists found proof of their theory in the history of Western Norway around 400 million years ago, where almost the same thing happened. You'd think India and Norway are worlds apart, right? But for geotectonics, that's just a minor detail. See you later.